All right, today we're talking about equations that have unique solutions, specifically equations with many solutions or no solution. So our objective says I can recognize the solution to single variable equations as one solution, no solution, or infinitely many solutions. So we have two example problems today that we're going to talk about, and then we'll do some together problems here in a second. So example problem A. It just says solve the equation. So we're going to work on solve this equation. We're going to see if we run into anything unusual as we do this. So the first thing is we'll eliminate these parentheses here. So just bring down 4x minus 5. 2 times 2x is 4x, and 2 times negative 1 is negative 2. This minus 3 is not part of that step, so just bring that down. It's not part of the distributive property. The next thing would be to combine like terms on each side. So we have no like terms over here, so just bring that down. But on this side we have negative 2 and negative 3, or negative 2 minus 3 that we could combine. So the 4x can't be combined with those things, but negative 2 minus 3 is negative 5. Now at this point you see that the two sides are exactly the same as each other. 4x minus 5 equals 4x minus 5. What's unique about that is that if we plug in anything for x, the two sides will come out equal. If we plugged in, let's say we plugged in 1, both sides. 4 times 1 is 4. 4 minus 5 is negative 1. 4 times 1 is 4. 4 minus 5 is negative 1. But not just if we plug in 1, if we plug in anything. Let's say we plugged in 2. 4 times 2 is 8. 8 minus 5 is 3. 4 times 2 is 8. 8 minus 5 is 3. Because whatever number we plug in, if we're always multiplying it by 4 on both sides, and then also subtracting by 5, if we're doing the exact same thing to the number on both sides, then it's always going to come out equal. So there isn't just one solution here. There's an infinite number of solutions because we could plug in anything. If we tried to continue solving this, let's say that you didn't recognize right away that these two sides were exactly equal. If you subtracted 4x on each side, you'd see that both of those cancel out. If your variable cancels out, and you end up with something like this, negative 5 equals negative 5, then you can see that that is a true statement no matter what, so you would still end up having the same answer on this, which is the phrase infinitely many solutions. Oops, wrote that a little too close to that. So if you do end up with that situation, you do have to write that, and you do have to write the whole thing. You can't just abbreviate it. Infinitely many solutions. Then we have this statement down here that says if the two sides come out to be exactly the same, then there are infinitely many solutions, as we see there. All right, the next one, let's go ahead and take a look at B. It has another unique solution, but different than this one. So let's take a look. We do not have any parentheses to get rid of, and we don't have any like terms to combine. So if we begin to try to solve this from here, we would subtract 4x on each side, like this. Those would cancel out, and you get 2 equals negative 5. But does 2 equal negative 5? Are those things actually true? They're not, right? So it's not equal. So if you end up with something like this, where they both really are equal, and you've eliminated your variables, then it's infinitely many. But if you've eliminated your variables, and there's nothing less to solve, and you end up with something that's not true, then the answer is no solution. There is nothing that we could plug into both sides to make both sides come out equal. And that's because we're multiplying both of them times 4. So let's say we plugged in 2 or 3 or whatever. If you multiply them both by 4, then so far they're exactly the same. But then over here you're adding 2, and here you're subtracting 5. Your numbers will always be 7 apart from each other, because 2 is 7 apart from negative 5. So just to show that to you, if you plug in 2 here and 2 here, 4 times 2 is 8. 8 plus 2 is 10. 4 plus 2 is 8. 8 minus 5 is 3. So it's 7 apart. It would be 7 apart no matter what you plug in. There's no way to make these two sides come out equal, because the two variable terms are the same, but then you don't have something that's actually equal once you simplify that down. So infinitely many solutions and no solution. This statement says if the two sides do not come out equal, then there is no solution. All right, let's flip over to the back side. Let's do some together problems. The instructions say determine if each equation has one, none, or infinitely many solutions. If there is only one solution, then you need to give that solution. All right, let's take a look at number 1 here. It's 3x minus 6 equals 4 plus 2x. So we're going to begin to try to solve this now. There are no parentheses. There are no like terms to combine, so it's just an equation with variables on both sides. So we got 2x over here and 3x there, so let's subtract 2x on each side. Let's see, 3x minus 2x is just 1x, or x minus 6 equals 4. We just continue to try to solve it as much as we can until we see something unusual. So we add 6 to each side, it looks like x equals 10. So there is one solution. No, that's right, one solution. And then it says if there's one solution, we need to give it, so that is x equals 10. Let's plug that in real quick and make sure that works. So we plug in 10. 3 times 10 is 30. 30 minus 6 is 24. Plug in 10 here. 2 times 10 is 20. 4 plus 20 is 24. So it even checks out that both sides come out to be the same with one solution there. Let's take a look at another one here with number 2. We've got 3x minus 8 equals 3, and then in parentheses x minus 4, and then in parentheses plus 1. Or sorry, outside parentheses, plus 1. Okay, let's begin to solve this and see what we run into here. There's no parentheses on this side, so just bring this down. 3 times x is 3x. 3 times negative 4 is negative 12. And then we have a plus 1 here. Now we look for like terms to combine. There's none over here, so just bring down 3x minus 8 again. Over here we have negative 12 and positive 1, so those can be combined, but 3x can't be combined with those. So negative 12 plus 1 is negative 11. If we can tell here, if the two variable terms are the same, that whatever we have here is going to determine whether or not this is infinitely many solutions or no solution. But if you were to continue to try to solve this, if you didn't recognize right away that the two were the same, those would cancel out. You get negative 8 equals negative 11. But the thing is, negative 8 doesn't equal negative 11, right? So if you've eliminated your variable terms completely, and this does not make a true statement like that, then this is no solution. You should be able to tell that from this step right here even. 3x minus 8 and 3x minus 11. If your two variable terms are the same, but then you don't have the same thing after that, if the two sides are not exactly equal after the variable terms are equal, you can tell that there's no way to make the two sides equal. You're going to multiply them both by 3, but here you're subtracting 8, here you're subtracting 11. So they're always going to be at least 3 apart from each other, so there's no solution there. Let's take a look at the last one here. Number 3 is 3x minus 7 equals 3. Then in parentheses, x minus 3. And outside the parentheses, plus 2. Okay, again, just bring this down. This is not part of the first step. The first step is distributive property. 3 times x is 3x. 3 times negative 3 is negative 9. Bring down your plus 2. Look for like terms to combine. There's none over here, so bring down 3x minus 7. Over here, you've got negative 9 and positive 2 that can be combined. So we've got 3x. Negative 9 plus 2 is negative 7. So once you see that the two sides are exactly the same, you don't have to work it out any further. I mean, you could subtract 3x on both sides, but that's just going to limit that and give you negative 7 equals negative 7. So as soon as you see that the two sides are exactly the same as each other, you can stop there and say that we know whatever we plug into both sides, they're always going to come out equal. This is infinitely many solutions. And you do have to write the whole thing there. All right. We're going to talk more about this. We'll do the on your own problems together in class. You guys see if you can get a handle on how to recognize when equations have some of these unique answers. We'll see you guys in class.